The secret to $1 million bottle of juice isn't in the machine, it's in the DNA. Before the first gear turns, the dominance of the wonderful variety. Not all pomegranates are created equal. In the world of the geography of the perfect fruit, the factory sources from two primary sunbelts, the Mediterranean and the Central Valley of California. This is a scale used to determine the percentage of sucrose in the fruit's juice. For a premium factory, the fruit must hit a minimum of 16 to 18 bricks. The internal pressure is at its peak when the pomegranate starts to look slightly hexagonal, meaning the fruit is literally bursting with juice. The deep crimson standard quart. Visual aesthetics aren't just for show. They indicate chemical maturity. The factory sets a color grade standard.
Weight is the ultimate truth teller. A high-tech harvest involves sample weighing. Pickers look for fruits that feel heavy for their size.
The golden hour of harvesting. Timing is everything. Harvesting usually begins at the break of dawn because the fruit is at its coolest temperature.
Workers use short blade bypass pruners to snip the stem as close to the fruit as possible. This prevents long.
If the calyx is crushed or removed during harvest, bacteria can enter the fruit and giant fans blast 40-degree air through the crates to set the fruit's temperature before transport. Standard wooden boxes won't cut it for this process. The factory uses heavy-duty, food-grade plastic bins with hundreds of ventilation slots.
Despite all our technology, there is no machine that can harvest pomegranates as well as a human. Mechanical shakers use
digital traceability, the orchard ID. Each crate is tagged with a QR code or RFID chip at the moment. The final step of the harvest is the cold chain. The fruit is loaded into 53-foot refrigerated trailers, maintained at a constant 4 degrees Celsius.
The gates swing open.
Before a single pomegranate enters the building, the entire truck is driven onto a massive weighbridge.
As the truck backs in, these seals wrap around the trailer to prevent outside air, dust, or insects from entering the facility.
The machine then slowly rotates the entire bin 135 degrees. It's a terrifying
Gravity drop and water cushioning. To prevent the fruit from bruising during the dump, they fall into a deep receiving pool. The water acts as a shock absorber. These are water-filled channels that use a gentle current to move the fruit. Water transport is the gold standard for hygiene and fruit integrity.
Buoyancy separation, nature's filter. As the pomegranates float down the flume, the factory uses physics to perform the first sort.
High-pressure pre-rinse. The water in the flume can get dirty quickly. As the fruit climbs the incline conveyor, it passes under a high-pressure spray bar.
Mechanical sizing grids. Not every machine in the factory is a computer. The diverging roller sorter is a masterpiece of simple geometry.
The optical color grader. Beyond rot, the factory cares about color. A series of high-definition cameras analyze the CIE lab color space of the skin.
As the fruit passes the final inspection, a laser sensor counts every single unit. This data is instantly synced.
A factory is only as fast as its slowest machine. To prevent a bottleneck, the fruit is temporarily held in vertical buffer silos.
The pomegranates pass through a sanitizing fog tunnel, where a fine mist of peracetic acid coats the fruit.
If a single speck of orchard dust makes it into the juice, the entire batch is ruined. We aren't just rinsing the fruit anymore.
As the pomegranates roll over these brushes, the bristles reach into the microscopic pores of the leathery skin, flicking.
To break down the natural waxes and oils, a precision dosing system injects food-safe detergent into the spray.
Following the soap application, the pomegranates pass under a series of V-jet spray nozzles,
These create a curtain of high-pressure fresh water. Clippers. Real-time pH water monitoring. The chemistry of the wash water is monitored every second by electronic pH probes.
Ozone pan. Infusion. For an extra layer of safety, many modern factories infuse the water with ozone gas.
The wash line produces a lot of sludge, mud, leaves, and stems. To keep the water flowing, the factory uses rotary drum filters.
The wash line speed must match the extraction machines. A VFD computer system monitors load set.
The fruit is now gleaming, dry, and 100% sterile. On the other side of this wall, the real surgery begins. Opening a pomegranate at home is a messy disaster. Now, imagine doing it to 200,000 pomegranates a day. High-powered lasers make shallow X-cuts or circular incisions on the crown and base of the pomegranate. This weakens the structural integrity of the rind. Barrels are heavy and sink to the bottom. Any remaining white membrane is buoyant and floats to the top. A skimmer arm removes the floating debris. Even at this stage, some seeds might be pale, unripe, or damaged. The stream of arils passes through a bichromatic optical sorter.
The rind ejector system. While the seeds move one way, the massive amount of skin moves another.
Maintaining the ruby integrity. A key for the factory is once separated, the arils are no longer moved on open belts. They enter closed aseptic tubes. This protects the seeds from the air.
The factory computer compares the weight of the incoming whole fruit to the weight of the extracted auricles.
High-frequency sound waves create microscopic bubbles that blast the screens clean while the machine is still running, ensuring a 24/7 continuous flow.
Temperature-controlled extraction room. This room is the coldest part of the factory. It is maintained at a shivering 2 degrees Celsius.
We have our rubies. Now we need the soul of the fruit. But there's a catch. If we press too hard, we release.
As the pressure begins, the first 40% of the juice released is known as the first run. This is the highest quality liquid.
The press is controlled by piezoelectric sensors that monitor the pressure in real time. If the pressure exceeds,
the wall of the screw press is actually a micro-perforated screen. As the juice is squeezed out, it passes through holes that are...
Oxygen is the enemy. The moment the juice leaves the seed, it wants to oxidize and turn brown. To prevent this, the entire press is blanketed with nitrogen gas.
What happens to the solids? At the end of the screw press, the dry, compressed remains of the seeds and skins are pushed out through a cone. The juice falls into a double-jacketed stainless steel trough, kept at exactly 2 degrees Celsius by circulating glycol.
The factory uses ultrasonic defoamers, devices that emit high-frequent sound waves that cause the bop instantly.
If a batch of fruit is less sweet than the standard, the computer automatically blends in juice from a sweeter storage tank to ensure every bottle tastes identical.
The factory doesn't just run at full speed. The flow rate is optimized based on the variety of the fruit.
The juice passes through a high-intensity magnetic trap that can catch a piece of metal the size of a grain of sand. This ensures the juice is 100% safe. The juice passes over a vibratory screen that uses gravity and motion to settle any heavy particulates like sand or
The juice is pumped into a 10,000-liter surge tank, which acts as a buffer. The juice inside is gently agitated. Right now, the juice is a bit of a mess. It's cloudy, it's thick, and it has tiny particles of fruit floating in it.
The first stop is the centrifugal decanter. Imagine a giant, horizontal drum spinning at 4,000 RPM.
For a second pass, the juice enters a disc stack centrifuge. Inside this vertical machine are hundreds of stainless steel cones stacked on top of each other.
Clarification and depectinization. Remember those enzymes we added in the last section? This is where they finish their job.
To prevent clogging, the factory uses cross-flow filtration. The juice flows parallel to the filter membrane at high.
The factory uses polymeric adsorbents, beads, that are designed to catch bitter tannins but let the healthy red pigments pass through freely.
The juice enters a vacuum deaerator. Inside this chamber, the pressure is dropped so low that any dissolved oxygen.
Brick standardization. Every pomegranate tree is different, but every bottle must taste the same. In the blending tanks, computers check the sugar levels.
If the light scatters too much, the batch is sent back through the filtration loop. For a premium clear juice, the NTU
Consistency is key for brand trust, and the spectrophotometer ensures the pomegranate red is perfectly on brand. The final filtration step is the polishing filter. This uses depth filters, often made of cellulose, to remove. From every 10,000-liter batch, a small reference sample is taken, sealed, and stored in a library. The juice is now refined, polished, and perfect. It is pumped into a sterile surge tank.
The juice is pure, but it's still alive. In its current state, it would spoil in days. To make it last,
The science of pasteurization. Pasteurization is named after Louis Pasteur, and in this factory, it's treated with religious precision.
The juice doesn't go into a giant boiling pot. Instead, it enters a plate heat exchanger. Imagine hundreds of thin
flash heating phase. The juice is flashed, its temperature is spiked rapidly from 4 degrees Celsius, 40 degrees Fahrenheit.
It passes through a final cooling stage using iced glycol. This thermal shock locks in the bright, tart flavor of the fresh pomegranate. Without oxygen present, the vitamins don't oxidize during the flash, allowing the juice to retain nearly 100% of its natural nutrient density.
From this point forward, the juice is sterile. It enters a closed-loop aseptic system. Every pipe, valve, and differential pressure monitoring. In the heat exchanger, the factory maintains differential pressure. The pasteurized juice is kept at a higher pressure than the raw juice. Because of the precision of this thermal treatment, the factory does not need to add preservatives like potassium sorbate or sodium benzoate.
The pasteurized juice is stored in an aseptic surge tank. This tank is basically a giant sterile thermos.
The juice is now safe, cold, and shelf-stable. It is a finished product, waiting for its container. It is
They are fed into a linear blow molder, where they are heated until they are soft, and then blasted with high-pressure air into a pomegranate-shaped mold.
The machine blasts the inside with ionized sterile air. This neutralizes static electricity and sucks out any
Laser level filling technology. We fill by laser volume sensing. The moment the juice hits the exact fill line, the valve shuts off with 99.9% accuracy.
Just before the cap goes on, a machine called a liquid nitrogen doser drops a tiny, freezing droplet of nitrogen into the headspace of the bottle. The bottles are immediately inverted for cap sterilization. The hot juice touches the inside of the cap, killing any bacteria in the threads of the lid.
By the time they emerge, the bottles are a crisp 10 degrees Celsius, preventing any after-cooking of the juice.
A wet bottle is a labeling nightmare. As they exit the cooling tunnel, the bottles pass through centrifugal air knives.
The Vision Inspection System. A series of 4 to 6 high-definition cameras perform a 360-degree inspection.
The individual bottles are then channeled into groups of 6, 12, or 24. A shrink bundler wraps them in a heavy-duty plastic film. The bottling line is done, but our journey isn't. We now enter the silent zone. The pallet spins at high speed while a roll of industrial-strength plastic film wraps it from bottom to top. The machine applies In a modern factory, you won't see many people driving forklifts. Instead, automated guided
A shuttle crane moves at 15 miles per hour down the aisles, lifting the pallets into specific honeycomb slots.
This warehouse is a giant refrigerator, maintained at a constant 2°C to 4. Sensors monitor the temperature.
FIFO inventory logic. The warehouse operates on FIFO logic. The computer system ensures that the oldest batch of juice is always the first one picked for shipping.
Because the AGVs and cranes use lasers and sensors to see, the warehouse can operate in total darkness.
When the transport truck arrives, it backs into a cushioned dock seal. This creates an airtight tunnel between the cold warehouse and the refrigerated trailer.
Real-time GPS temp tracking as the pulls away.
This digital document proves to customs and health inspectors that the juice has been tested for pathogens and meets all food safety regulations.
The final handoff. The juice has officially left the factory's control. It is now in the hands of the global supply chain, moving toward the supermarket shelf.
In this factory, waste is a forbidden word. We've bottled the juice, but what happens to the mountains of skins?
The thick, leathery skins we discarded back in Section 4 are transported via a separate conveyor to the byproduct refinery.
Pomegranate seed oil, the liquid gold. The woody seeds left over from the press are a hidden gold mine.
Pomash livestock feed. What's left after the oil is squeezed out? A nutrient-dense fiber called seed cake.
Inside that same anaerobic digester, the bacteria produce methane gas. The factory captures this gas and burns it.
The deep red color of the pomegranate skin is incredibly stubborn, which makes it a perfect natural dye. The factory
of the Midgiller. The roof of this facility is covered in high-efficiency bifacial solar panels. On a sunny day, these panels generate
Composting the final fines. Any organic dust or microscopic solids that can't be used for oil or feed are sent to the industrial.
These essential oils are used in the flavor and fragrance industry to create everything from pomegranate-scented candles to natural soda flavorings.
This factory prides itself on its zero landfill status. Every single input, from the wooden pallets to the plastic.
This industrial symbiosis ensures the factory isn't a drain on resources, but a vital part of the regional water cycle.
Samples treated with the tannin extract are holding up better. Look at this data. Microbial growth is inhibited.
That confirms it. Pomegranate is the key.
The full circle, the final sip. The story ends where it began, with the fruit. As the last